Section 7.4 is dealing with polynomials. A polynomial is a monomial or the sum of monomials. Terms separate the monomials with a plus or minus sign. We have several different types of polynomial. The first one is a binomial, which is a two-term polynomial. And a trinomial is a three-term. Now let me give you an example of a binomial. It would be x plus 6. That's an example of a binomial, two terms. A trinomial is a three-term polynomial. An example of that would be x squared plus x plus 6. The degree of a monomial is the sum of the exponents. And the entire degree of a polynomial is the greatest degree. Okay, example 1, determine whether each expression is a polynomial. If so, identify the polynomial as a monomial, binomial, or trinomial, and also state the degree. 4y minus 5xz. What type of, is this a polynomial? Yes, it is. And what type is it? Binomial. Now, the degree, and what I mean by that is what is the degree of the entire polynomial? So we have to look at the degree of each term. What is the degree of the first term? 1. What is the degree of the second term? We add the two exponents, and that's a 2, so the degree is a 2. Okay, for that term is a 2. And so the degree of the entire polynomial is whichever degree is the largest. And what is the largest degree? 2. So it is a 2-degree polynomial. Negative 6.5. Is that a polynomial? Actually, it is. A polynomial can be one term, and it can be just a number without a letter. So you've seen these numbers forever, but you never knew that was called a polynomial. But yes, it is a polynomial. And what term is it? A monomial. Now, if it doesn't have a variable, it does not have a degree. So the degree is 0. The third one, 7a to the third plus 9b. Is this a polynomial? Yes. What type? Binomial. Now, what is the degree of the entire polynomial? We have to look at each term and calculate the degree of each term. What is the degree of the first term? 3. What is the degree of the second term? 1. So what is the degree of the whole polynomial? 3. The next one, how many terms is in this polynomial? It's a 4. First, is it a polynomial? Yes. And it's a 4-term polynomial. Is there anything, a special word? No, we just call it a polynomial. It's a 4-term polynomial. You can say a 4-term polynomial, but there's really no special name for it. Now, what is the degree of the whole entire polynomial? What is the degree of the first term? 3. What is the degree? Actually, oh, wait a minute. Look here, guys. Could I have added those two together? And when I do that, what do I get? 6x to the third plus 5x plus 3, which is a trinomial. So it's no longer a 4-term polynomial. And the degree of the first term is a 3, the degree of the second term is a 1, so, and the degree of the third term is 0, so what is the degree of the entire polynomial? 3. And the next one, is it a polynomial? Yes. It's a binomial. Now, the degree of the first term is a 2. The degree of the second term is 3 because we add up all the exponents. So what is the degree of the entire polynomial? 3. Look at the next one. I can combine negative 2y plus 4y, and so I would get negative 3y squared plus 2y minus 1. Is it a polynomial? Yes. And it's a trinomial. And what is the degree? 2. Okay, look at the very last one. 10x to the negative 4 minus 8xa. Is this a polynomial? Well, it's not, and only because look at the very first term. That's an x to the negative 4, which we would have to rewrite that as 10 over x to the 4th. Find the degree of each polynomial. So what we have to do is we have to get the degree of each term, and then whichever one is the largest, that's the degree of the entire polynomial. So look at the first term. What is the degree of the first term? 5. And 0 has a degree of, 6 has a degree of 0. So what is the degree of the entire polynomial? 5. So the degree is 5. Example B, the degree of the first term is 3. What is the degree of the second term? 6. And what is the degree of 7? That is 0. So what is the degree of the entire polynomial? 6. And example C, how many terms is this?
7.
How many terms? It's just one term, right?
Yeah.
So we have to add them all up. And so what is the degree?
7.
The degree is 7. Very good. And example D, the degree of the first term is 2. The degree of the second term is 3. And the degree of the last term is 4. So what is the degree of the entire polynomial? 4. The standard form of a polynomial is written with the terms in order from the greatest degree to the least degree. When it's written in standard form, the coefficient of the first term is called the leading coefficient. Example 3 says, write each polynomial in standard form and identify the leading coefficient. So we have to rewrite this. What would the standard form be? We would rewrite this, what would be first? 4x to the 5th plus 3x squared minus 7x. There it is in from the greatest degree to the least. And what would the leading coefficient be? The leading coefficient is 4. Example B, we're going to rewrite this as negative 2y to the 4th plus 5y minus 9. And the leading coefficient would be what? Negative 2. Example C, the largest exponent is x to the 4th, so we're going to rewrite it as 4x to the 4th minus 2x squared minus 3x plus 8. And the leading coefficient is 4. And example D, negative 7y to the 6th plus 5y to the 3rd minus 2y to the 2nd plus y plus 10. And the leading coefficient is negative 7. From 2000 through 2006, the number of U of skateboards in thousands produced at a manufacturing plant can be modeled by the equation U equals 3t squared minus 2t plus 10, where t is the number of years since 2000. How many skateboards were produced in 2002? So how many years is that from so at 2000 is where we start. So in 2002, how many years is that? 2. So what are we going to do to find out how many skateboards were produced? Plug 2 in for t. So U is equal to 3 times 2 squared minus 2 times 2 plus 10. Simplify using the order of operations. 2 squared is 4 times 3 is 12 minus 4 plus 10. And 12 minus 4 is 8 plus 10 is 18. Now that's 18 skateboards were produced? 18 thousands, because remember it's in thousands. So 18,000 skateboards were produced in that year. Example B, how many skateboards were produced in 2005? So what would we plug in for T in this case? 5. Five squared is 25 times 3 is 75. Minus 10 plus 10 is 75. And again, that's 1,000 skateboards. Example C. If this trend continues, how many skateboards will be produced in 2015? So what are we going to put in for 2015? 15. So 3 times 15 squared minus 2 times 15 plus 10. Now here's where a calculator definitely comes in handy. 15 squared is what? 225 times 3. So 675 minus 30 plus 10 is 655. And that's 655,000. There is your assignment.